Hey guys, this is our first set of notes for Unit 4A. This is technically a review from Integrated Math 2. So we got a new little digital notebook at the front. This gives you some reminders. You need to make sure that you put in your notes the day that you take them. Don't wait till your notebook is due. You just delete the photo that's on the slide and add yours in. The notebook's due the day you take your test. Which is going to be next Friday. Each slide is just worth 5 points, and then you're allowed to use notes on quizzes but not on tests. Make sure everything's handwritten, and then the photos are clear and easy to read. All right, so at the top of your paper, you guys can go ahead and put the title. These notes are linear inverses. You don't have to write down the essential question, but at the end of the notes, you want to be able to answer, how can you tell if two functions are inverses? What are the steps to find the inverse of a linear function? So inverse functions, we talked about like sine and sine inverse when we were doing trig stuff. What inverse functions are they're just two functions that basically reverse each other. Adding and subtracting are inverses, multiplying and dividing are inverses, they undo each other. So inverse functions are just two functions that reverse each other. What that also means is that if you compose the two functions together, f of g of x is how you would read this, is going to be equal to x, and g of f of x would also be equal to x. So when you plug one function into the other, your answer would just be x. So I'm going to show you an example of two functions that are inverses of each other. So go ahead and write down those two functions, f of x and g of x. So what it means to do function composition means you're taking one function and plugging it into the other. So like see how g of x is where the x normally is. So what you're going to do is take all of g of x and plug it in where the x normally is. So 2 times 1/2 x plus 2. And then there's still that minus 4 at the end from the function. So we just took this function right here, the 2x minus 4, and where the x was, we plugged in g of x. Now when we simplify this, what's going to happen is everything's going to cancel except for x, because 2 times 1/2 of x, well, 1/2 of 2 is 1, so that's just x. 2 times 2 is 4, and then there's a minus 4 at the end, so it just cancels and equals x. Then I'm going to do the same thing where I'm going to take my function f of x and plug it into g of x. So this is my whole function f of x, and I'm going to plug it in for the x in g of x. So 1/2, instead of x, I put 2x minus 4, and then I still have that plus 2 at the end. And then if I distribute and simplify, I'm going to be left with just x, because these functions are inverses. So 1/2 of 2x is just x, 1/2 of -4 is -2, add 2, and we're just left with x. So they are inverses of each other. So here's a real-world example of inverse functions. So you guys can go ahead and write down the problem. The real-world example, tickets to a baseball game are $30 and parking is $10. You can draw this little table. So if I told you how many tickets I was buying, you could probably figure out the cost, right? And there's an equation we could write with it. But what if I gave you the cost and asked you to find the number of tickets? They're kind of inverse functions. One undoes the other. So like say I drove to the baseball game. It's just one person in the car, drives to the game, and buys a ticket and goes in. Well, it costs that person $10 to park, and then they buy one ticket, so it's $10 plus $30 is $40. If there was two people, the two people driving their car, they pay $10 to park, but then they have to buy two tickets. So it'd be $10 plus 30 times 2, so that would be 70. If 3 people drove in the same car, they paid $10 for parking and then $30 for each of their tickets. So it'd be 30 times 3 is 90, plus 10 is 100. 4 people all drive in the same car. They spend $10 to park, and then each ticket is $30. So you multiply that by 4. So 30 times 4 is 120, and then you add your $10 is 130. So you could write an equation to go along with that. The number of tickets is equal to, you pay $30 for each ticket, so that'd be 30x, plus you pay $10 just to park your car. So that would be like our function for the, oops, that wasn't t, sorry. The cost would be $30 for each ticket, t is the number of tickets you buy, plus $10 to park. Sorry, the total cost is equal to, the tickets isn't equal to that. But what if I went the other way? What if instead I gave you the cost and wanted you to find how many tickets there were? So all the people drove in the same car, right? They parked the car and they paid $220. Well, how could you reverse it and find the number of tickets? Well, you know they paid $10 to park, so you would subtract the $10 for parking, and then you know that they paid $30 for each ticket, so you would divide that by 30, right? So you would subtract 10 and divide by 30. So 210 divided by 30 is 7. So 7 people went in their car. If it was 310, you would subtract $10, right, for the parking, and then you would get 300. You know, each ticket is $30, so you would divide by 30, and you would get 10. All right, well, that function then, if you wanted to find the number of tickets, this time we were finding tickets, you would take how much the total cost was, we subtracted 10, and then we divided by 30. So they're inverse functions of each other. They reverse each other. So notice how this one has a plus 10, this one has a minus 10. Notice how this one has a times 30, this one has a divided by 30. So they have the inverse, the opposite operations. All right, let's talk about how to find an inverse given. We're going to look at given a set of points, given a graph, and given an equation. So how to find it given a set of points, really easy. All you have to do is switch the x and y values. So an ordered pair is normally x comma y. You're just going to switch it to be y comma x. Let's do a couple of examples. One is given it as like a set, and then one's given as like a table. So first example, it gives us just a little set. It has the point 3 comma 4, 1 comma negative 2, negative 5 comma 1. So the inverse, like I said, pretty easy to find. We're just going to write it still as a set. It's like the brackets. There was 3 points in the original, so there's going to be 3 points for the inverse. And all you have to do is switch x and y. So the first point is 3 comma 4, so I switch that and make it 4 comma 3. The next point was 1 negative 2, so I switch it to be negative 2 comma 1. So the signs go with it. Negative 5, 1 becomes 1 negative 5. And that's it. That's all you have to do. That's our answer. If they give it to you in a table, so our next example gives it to us in a table. You want to write that down. And then the inverse, you make a new table, right? You just do the same exact thing. You switch x and y. So my original was negative 2, negative 3. So it becomes negative 3, negative 2. Then it was 1, 0. So that becomes 0, 1. And 4, 3 becomes 3, 4. So if you're given a set of points, really easy. All you have to do is switch x and y. All right, so this is going to be one picture that we put on our set of notes. So I'm going to go to a new paper. Sorry, my thing's messed up. Now we're going to talk about how to find it if you're given a graph. So draw this little graph. I'm going to plot these points. So this is going to help you when you're drawing your little graph would be to, like, first thing you want to do is just identify what your 2 points are. So you're going to kind of make a table like what we had on that last example. So this first point up here is don't go right or left at all. You just go up 1, 2, 3. So that's the point 0, 3. And then we have another point over here. This is, you would go right 1, 2, 3, 4, 5, and then down 1. So right 5, down 1 would be 5, negative 1. So then your inverse, okay, so to do the graph, you just have to identify some points, and then you just do your inverse where you now switch x and y. So when I switch, 0, 3 becomes 3, 0. 5, negative 1 becomes negative 1, 5. I'm going to plot those points, and it's still going to be a line. So 3, 0, right 3, not up or down at all. Negative 1, 5 means left 1, and then up 5. And then I go ahead and just draw a line there. Something that you need to know about the inverse graphs is that the inverse graphs are a reflection across the line y equals x. Y equals x. So this is the line y equals x. It's a diagonal line going through quadrant 1 and quadrant 3. And it's a reflection across that line. So when you reflect it, this part goes down to this part goes up to this. So they reflect across that line. All right, so here's the main one. Here's what your homework problems are like. We're going to talk about how to find the inverse if you're given the equation, and we're just going to have 4 little steps. Pretty easy. All right, so step 1, okay, if your function is if it's written in function notation, which means it has like a f of x in front of it, then you're just going to first replace f of x with the letter y. Step 2, you're going to go ahead and switch x and y. Just like we've done for all of our inverses, we just switch x and y. Step 3, you're going to go ahead and solve for x. Nope, solve for y, I mean. And the last step is to go ahead and replace y with the inverse notation, which looks like this. So it looks like f to the power of negative 1, but the way that we say it out loud is we say f inverse when we say it out loud. So we're going to do 2 little examples doing these 4 steps. So example, our first one is f of x equals 4x minus 2. And then we'll do negative 3x plus 5. They're 2 linear equations. We're just doing linear, and then we'll do quadratic and cubic and all those good things. Okay, so first step, replace f of x with the letter y. So f of x is y. That's step 1. Step 2 is to switch x and y. So I switch and I get x equals 4y minus 2. Step 3 is to solve for y. So now I'm trying to get this y by itself. So the way that you get the y by itself is you would move anything that's being added or subtracted. So I'm going to add 2 to both sides. And then I would go ahead and divide both sides by whatever's in front of y. So I'm going to divide both sides by 4. So when you divide both sides by 4, everything gets divided by 4. So a lot of times you write it as a fraction because it's a line, and so you want it in slope-intercept form. So the number in front of your x is technically a 1. So it'd be 1/4 x plus 2 divided by 4 could simplify to 1/2. That's equal to y. But you want to replace y with f inverse. So you put f inverse of x, and then that would just be my answer. So it's in slope-intercept form. So these are all lines, remember? So this is the slope, and this is the y-intercept. All right, let's do one more, and then this is what you guys are going to do for homework tonight. So my next one is f of x equals negative 3x plus 5. So the first step is to replace f of x with the letter y. Step 2 is to switch x and y. So this x becomes y, this y becomes x. You switch the two. Then you solve for y. So to solve for y, I'm going to go ahead and move whatever's being added or subtracted. Get x minus 5 equals negative 3y. And then to get y by itself, I have to divide by negative 3. So I divide everything by negative 3. So y is by itself. Remember, we're trying to write it as like y equals mx plus b form. So this is my number in front of x is 1. So that's negative 1/3 x, because we normally move the negative to the top or the front. And then negative divided by negative is positive. So it's positive 5/3. And then the last step is just replace y with f inverse. So we put f inverse of x. And that would be my answer. So if I take this function and plug it in right here, it would all cancel just to equal x. Or if I took this whole function and plugged it right here for x, they would all cancel and it would equal x. They're inverse functions. They undo each other. They reverse each other. Okay, so on our new digital notebook, I have it set up a little bit differently. I have the table of contents filled in for you already. So our notes are going to go on slide 5 and 6, linear inverses. So you go to slide 5, that'll be your first page. It's only one picture per page now, instead of having the two sides. So maybe if they're larger, it'll be easier to read and whatnot. So slide 5 and 6 is where you guys are going to go put your notes for today. And that's it. Your homework's on Khan Academy.